Your new air conditioner was engineered to fail before your car loan's paid off. Your $10,000 system just died, and the technician says it's cheaper to replace the whole unit than fix a leaking coil. This is the business model, not a defect. Manufacturers replace 20-year copper with aluminum that can't be repaired, thin the walls so invisible corrosion eats through faster, and added digital locks that reject off-the-shelf parts. We're going to trace the 3 boardroom decisions that turned a generational machine into a 5-year appliance. The 5-year death. Your air conditioner is the most expensive mechanical system in your home, and since 2020, the price of a new unit has jumped about 40%. Carrier pushed 6 to 8% in 2025 alone, and Lennox went up 10. Tariffs on imported components are adding another 15 to 30% before the unit even reaches the supply house. You're paying dramatically more for systems that last dramatically less. In the 1990s, a properly installed central air system lasted 15 to 20 years. The ductwork was galvanized sheet metal, the compressor was simple, and the technician who installed it lived in your zip code. Today, the average lifespan is 10 to 15 years, and in hot, humid climates, many burn out in 8 to 12. The industry shortened the replacement cycle while doubling the price per cycle, and that's not inflation. That's planned obsolescence with a thermostat attached. The failure isn't random because it concentrates in one part, the evaporator coil inside your indoor unit. Industry maintenance specialists note that evaporator coil corrosion happens frequently, and class action filings against Goodman and Johnson Controls have documented thousands of claims over prematurely leaking copper coils. A 2025 investigation into Carrier copper coils is still active, and consumer forums show homeowners on their 3rd coil replacement inside 5 years. This isn't a string of bad luck. This is a pattern, and patterns don't happen by accident. The aluminum crime. The first boardroom decision was about metal. Copper has been the standard for HVAC coils for decades because it conducts heat about 60% better than aluminum, and it resists corrosion in most environments. A technician can locate a leak, clean the area, and braze it shut on site. A pinhole in a copper coil used to be a service call that cost you a few $100s. Now it's often a parts order that runs into the thousands. Copper prices have surged to more than 3 times the price of aluminum per ton, and manufacturers face relentless pressure to cut costs. Industry analyses show that switching from copper tube to aluminum tube, or all-aluminum microchannel designs, can reduce coil manufacturing costs by 20 to 40%. When you're building millions of units, that margin is impossible to ignore. But the switch is about more than raw material cost. Aluminum coils, especially microchannel designs with flat multi-port tubes, aren't field repairable. The tubes are too thin and too intricate to braze on site. And even when specialized repair kits are attempted, the fix rarely restores original performance. When a microchannel coil leaks, the standard practice is coil replacement, not repair. Manufacturers didn't just choose a cheaper metal, they chose a metal that turns a fixable problem into a sale. The trade-off is hidden in the spec sheet. Copper coils cost 1.5 to 2 times more at the manufacturing level, but they can last 15 years or more and survive a repair. Aluminum coils may cost less upfront, but when they fail outside warranty, you're buying the entire coil assembly, not a 30-minute braze job. The homeowner pays the difference, and the manufacturer books another parts sale. The copper industry calls this a performance optimization, but technicians call it a durability downgrade. The balance sheet calls it profit. The invisible enemy. The second boardroom decision is harder to see because it happens inside the metal itself. It's called formicary corrosion, and it creates microscopic tunnels inside copper tubing that eventually become pinhole leaks. The name comes from the Latin word for ant, because the corroded tunnels look like ant nests under a microscope. You can't see the damage from the outside until the refrigerant is already hissing out. Formicary corrosion needs 3 things: moisture, oxygen, and an organic acid. All 3 are present in modern homes. Tighter building envelopes designed for energy efficiency trap volatile organic compounds from cleaning products, adhesives, paints, cosmetics, and air fresheners. These chemicals oxidize into formic and acetic acid that condenses on the cold surface of your evaporator coil and stays there in the stagnant pockets between fins. Carrier's own industry research identifies this as one of the leading causes of residential coil failure. And the engineering gets cynical right here. R410A and the push for higher efficiency ratings forced manufacturers to use thinner copper tube walls and smaller diameters. Thinner walls transfer heat more efficiently and use less raw material, but they also mean there's less metal to consume before a tunnel becomes a through-wall leak. The same corrosive environment that a thick-walled 1990s coil could survive for 15 years now eats through a modern coil in 3 to 7. The lawsuits back this up. Filings against Goodman and Johnson Controls allege that certain coil generations were defectively thin, with plaintiffs claiming as much as 80% of products with a particular design were affected. A fresh Carrier investigation in 2025 is adding more claims to the pile. The failures cluster just outside standard warranty periods, which isn't a coincidence. It's a timeline, and timelines are written in advance. The diagnostic ransom. The third boardroom decision is digital. Modern HVAC systems run on microprocessor-based control boards that monitor temperatures, pressures, and electrical loads in real time. These boards are marketed as smart diagnostics and energy optimization, yet they perform another function too. They authenticate replacement parts through proprietary digital serial numbers. If your control board dies and you install a replacement that wasn't digitally authorized by the manufacturer, the system rejects it. The board flashes an error code, and the unit stays dead. The part is physically identical and electrically compatible, but it's not digitally paired, so the machine treats it as unauthorized. The problem was never compatibility, it was always control. And what comes next proves it.
This isn't theoretical. Patents filed by major manufacturers describe configurable thermostat locks, remote monitoring systems that can disable operating modes from a distance, and tiered reset capabilities that reserve advanced diagnostic functions for authorized technicians with proprietary tools. The local repair shop that used to compete on price and skill can't get the software or the pairing keys. The manufacturers have locked out independent shops and made it nearly impossible for anyone except their own authorized network to turn a profit doing the repair. Every feature that makes your machine harder to fix is a feature that makes the manufacturer more money. You paid for the hardware, but you didn't buy the right to operate it. That's diagnostic ransom, and it's built into the circuit board. The escape route. So the question isn't whether the game is rigged, you already know it is. The question is whether you'll keep playing. If you're buying a new system, demand copper tube coils in writing. Specify round tube copper with adequate wall thickness. If the contractor pushes all aluminum microchannel, ask why they're recommending a non-repairable assembly. Verify the service infrastructure before you sign by calling the manufacturer and confirming the nearest authorized technician and their response time. If it's more than 1 week, that brand doesn't have real coverage where you live. Insist on manual J and manual D calculations in writing so the system is sized correctly for your house. Demand rigid galvanized sheet metal ductwork because flex duct degrades in attic heat and leaks 20 to 30% of the air you're paying to cool. A $12,000 system that lasts 20 years is cheaper per year than an $8,000 system that dies in 5. The difference isn't the brand. It's what you demand before the truck ever shows up. That's the real audit. And if you want to see the next one, we're pulling apart the tool aisle at Home Depot.